All right, so we're combining 8.1 and 8.2. We're going to call it Intro to Vectors and Vectors on the coordinate plane, the Cartesian plane, in other words. And this is mostly going to be a lot of definitions, because it's an introduction to all this. So, we're going to define a vector. A vector is a quantity with both magnitude and direction. Just as the guy in Despicable Me said several times over and over.
Vector.
Yes, vector. So that's a vector. Of course, if you're going to define a vector that way, you need to know what those terms are. So, definition, magnitude. Is a measure such as distance or speed and other things. And then below this, the magnitude of a vector on the Cartesian plane is the length of the vector. As a bit of an aside here, I have speed written as a measure because speed in itself does not have a direction related to it in any way. If you talk about the speed of your car, you could jack it up and just run the engine so the wheels are spinning. You could run the engine so the wheels are just spinning. And it would still generate a speed. The car would have a speed, but no direction. Velocity, on the other hand, is defined as a vector, which means to have a velocity in a car, you must not only be spinning the tires, but it must actually be going. So, the difference between speed and velocity is that speed is a magnitude, velocity is a vector, because it includes a direction. Okay. So let's talk about direction. Not in particular anything real hard. It's where a vector is traveling. Where a vector is traveling. But on the Cartesian plane, direction is defined by guess what?
By magnitude, by vector, by speed, by measure, by distance.
The direction of a vector on the Cartesian plane is defined by the angle created between vector and the x-axis. Not that you have to necessarily start at the x-axis, but that at least you have to be parallel to it.
So vectors are,
We're going to draw a vector here, just in a moment. So here's what a vector looks like on the Cartesian plane. For those of you watching at home, that was AJ dropping stuff.
I collect snapping photos.
So here's what a vector on the Cartesian plane looks like. It might look like that. The arrow is part of the direction. The magnitude is how far it is from here to there. And as part of the direction also, we would take the line directly parallel to the x-axis and we would measure that angle theta. And so that would be part of the direction as far as the Cartesian plane is concerned. So we got to know where it's going, whether it's going that way or that way. And we also have to know how far it is angled from the x-axis or from something parallel to the x-axis. Questions?
is there, how do you know where to begin to find the angle measure? Right there?
Wherever this is, and you draw an imaginary line parallel to the x-axis. Wherever it starts.
So how would you get the number? Like, wait,
A protractor.
okay. I thought there was like an equation.
Or you'll be told, or you'll have some point of reference. Like you'll know what this point is, what this point is, and then you can use trigonometry to generate the angle, any of those ways. Other questions? No? Okay.